Okay, guys, if you're watching, just put into the chat or the comments, pop your name so I know who's here. So, guys, if you are watching live, I'm going to wait till 1:30 to start, because that's what I just sent an announcement out to parents and to pupils. But when you do get here, just write your name in the chat so I can see who's here. Hope you're all well. Working hard, obviously. Okay, so let's say lesson will start in about 10 minutes. If you're watching live, brilliant. If you can't and you watch it later on, that's fine. This is kind of the format that I'll try and do next week as well. But when you log on, if you can hear me, just pop your name in the chat so I can see who's listening. if you can't do that, just ping me an email so I know that the chat's not working for you or something like that, just so I know who's watching, because then I can be asking questions as I go to help you out. True teacher style though. I'm going to go make a coffee while I'm waiting. So I'll say again, if you are watching, just pop your name in the chat so I can see who's here. Doesn't matter if you're watching it later on, that's fine. But then at least if I know someone's here, I can ask questions and answer questions if need be, if you need help. So about 4 more minutes. There is about a 30-second delay, so apologies if I don't get back to you straight away. or if it seems like you're having to wait for a little bit whilst we're going through the questions. Okay, so I make it 12:30, so I'm going to make a start. If people arrive, just put something in the chat to let me know so I can see. And then I'll answer any questions as I go if there are people there. If not, not a problem. You can watch the video later on. So, just to start off, this is the Unit 5 review. I'm going to go over some of the tasks that you've been doing over the last 2 weeks. Hopefully I'm going to answer some questions that people asked me to go over. I have had 3 replies asking me about certain questions, so I'm going to try and cover all those. the way that we're going to get more out of this, guys, is if you tell me what you want me to go over, then I can go over it. If you're sat there and you're not really sure of how to do Fibonacci sequences or how to do the algebra for the quadratics, then you're going to struggle. You need to ask the questions so that we can actually have a go. Sorry, just having a little drink there. If you've already answered the questions that I go through today, because some of them are from, well, most of them are from work that you've already done, then just drag forward to the answers if you're watching this afterwards. Click forwards. If not, watch the explanation, and if you've got any questions, then either put them in the chat, email me, or comment on the video afterwards, okay? It's just to get an idea of what you know, what you don't know, and if you're going to be ready to have a crack at the test. So, let's crack on. First question I was asked about was how to deal with nth term questions. In fact, this was from Jamie. Jamie asked about question 10 and 11 on one of the homeworks the other day. And this was from Corbett Maths. So you're told that you've got the nth term of a sequence is n squared plus 3n, and that two consecutive terms in the sequence have a difference of 38. Right? So, first off, you need to identify what type of sequence it is, and your answer is there. You've got n squared plus 3n. So, is it a linear sequence, or is it a quadratic sequence, or is it some other type of sequence that we don't know? Well, the key from what we've been looking at before is to look at the power. So in this case, we've got the power of 2. We've got that power there is squared, so that means it's a quadratic sequence. Right? So that's a good thing to notice first. We're then looking for two consecutive terms. That just means one term after another. Just means, so we're looking for like the first and then the second term, or the third and the fourth term, but we don't know which ones, but they need to have a difference of 38. So really, all you need to be doing is actually going through the motions of writing out each of the terms in the sequence. So we normally do the first 5. So n, remember, this just means the place in the sequence. Well, it's the term number. So this one is the first term. This one is the second term. This one's the third. This one's the fourth. This one's the fifth. And all you do is you substitute that in for n. So if we've got n squared plus 3n, when n is 1, 1 squared plus 3 multiplied by 1 is 4. 1 squared is 1, plus 3 multiplied by 1 is 3, so we make 4. Next we've got 2, so it's 2 squared, which is 4, plus 3 times 2, which is 6, so we get to 10. And you might want to, because we need to be looking for where there's a difference of 38, you might want to just say where you've got the differences. And here we've got a difference of plus 6. Right. Could try the next one. 3 squared is 9, plus 3 multiplied by 3, so it's got 18. So we're going to go plus 8. Now we need a difference of 38, so this is going to go on for a little while. But as long as you just follow the process, you will get there. This is not the quickest way of doing it, but it's the way I recommend for you guys to have a go. So that's gone up by 4, that's going to go up by 8, that's going to go up by 10. Next one's going to go up by 12. So that's 40. Next one's going to go up by 14. Is it? No. No, I'm making massive assumptions here because I'm assuming. No, I'm not. I am doing it right. Yeah. Then I've lost my train of thought now. For 54, no, I'm using the rubber. 54, and then plus 16, so 70. If we go down here, it'll be plus 18, so it'll be, so this is the 8th, 9th, 10th, 11th term. I'm just going to keep going down. 12, 13, 14, so we're on 70, we're adding 18, so it'll be 88, adding 20, 108, adding 22, 130, adding 24, 154, 26, 180, adding 28, 208, adding 30. So we're getting close now. 238. Carry on down here. So then now we're going to have that n is 15, 16, 17, 18, 19, 20. So we're adding 32 now, which will get us to 270. Adding 34, which is 304. Adding 36, which is 340, and then we're adding 38, which is 378. So going back to the question, two consecutive terms with difference of 38. You have a 340 and 378. Those would be the ones that you are looking for. All right. So just going through now. Notice what I did there, just to go over it. I worked out these first few, so I was substituting in 1 squared was 1, plus 3 times 1 is 4, multiplied by 1 is 4. And then 2 squared is 4, plus 3 multiplied by 2 is 6, so that gives you 10. I did those ones, and then I looked for a pattern, so it was plus 6, then plus 8, then plus 10. And because I was getting this pattern, I could then say that it was going up 2 each time. So then I didn't have to keep substituting in because that would be tricky. I just kept on adding 2. And yeah, it took a little while to get there, but eventually, scrolling down, you get to where you've got your 2. So there's your answer, 340 and 378. Hopefully that's helpful for you, Jamie. Any questions? Obviously let me know. Now, this one says, prove that every term in the sequence n squared minus 4n plus 21 is positive. Well, this is where you need to remember one of the rules that we learnt in year 8. But first off, what we're going to show is we're going to show the first 5 terms again. And then I'll come to the other bit. So this is the place in the sequence again. Remember the term, yeah, the term number. So when n is 1, that means the first term, the second term, the third term, the fourth term, the fifth term. So just substitute in each of these values. 1 squared is 1. Minus 4 multiplied by 1, which is negative 4. So 1 subtract 4 is negative 3. Add 21 is 18. Okay, check that on a calculator if you need to. Then you've got 2 squared minus, which is 4, minus 4 multiplied by 2, which is 8, so on negative 4, add 21 is 17. Just check that through. 2 squared is 4, minus 8 is negative 4, add 21. Alright, okay. It's going down. N squared is 3. So 3 squared is 9, minus 12, because negative 4 multiplied by 3 is 12, so 9 is negative 3, add 21 is 18. Oh, hang on a minute. 4 squared is 16, minus 4 is 0, plus is 21. Right. And then 5 squared is 25, minus 4 multiplied by 5 is negative 20. 25 take away 20 is 5, add 21 gives you 26. Now you should be able to spot some patterns or what's going on here. So here we go down by 1, then here we go up by 1, then we go up by 3, then we go up by 5. If this was a linear sequence, remember we talked about this before, if it was linear, those are the first differences. The first differences would all be the same, but they're not, which means it's quadratic. But we know that from up here because we've got our n squared value. That's the highest power of the variable, so therefore we know it's a quadratic. However, we can then see that these are all going up by 2s as we go from left to right. So the next one here would be 7, the next one would be 9. Going the other way, we would have negative 3, negative 5. If we were to go to the negative terms, but can't have the negative first. Well, you sort of can. But what we also need to spot is this, what's going on here. Can't see where I'm pointing there. Get the arrow. What's going on here? Yeah. We start with 18, we go down to 17, and then we go up to 18. So this is what looks like our lowest value within the sequence. Because if that's 18, if we were to go back this way, let's say we were to go to the 0 term, what do we think this term would be? Well, there's an easy way to work it out. If you imagine n to be 0, let's just turn that into a 0 a second. So the 0 term, 0 squared, 0 multiplied by 0, 0, minus 4 multiplied by 0, 0, add 21. Okay, well, it's just 21. Oh, there's a pattern. 21, 18, 17, 18, 21. So these numbers are duplicated effectively. And that's because a quadratic, if you imagine the graph, where are you going to be able to see this? Let me draw it below. If you imagine the graph of the quadratic, your quadratic is going to make a curve that looks like that. Or something like that, maybe more like that. Right? And that curve can go anywhere along here, anywhere at all. But what it is symmetrical. Now, I haven't drawn it very well because I've done it freehand, but it's symmetrical. So that means that these numbers are going to repeat. So the next one over here would be 26. So that it matches up, so it's symmetrical. So that means that this is the lowest value. If that's the lowest value, then you have proved what you wanted to prove, Jamie. Hopefully you've understood that they're all positive because it's never going to go below 17. 17 is what's called the minimum. Yeah? So this point here is going to be at 17, where the what on the y-axis. Yeah? So let me just try and draw that for you. Oh dear, that's horrible. That's because it's far too thick, that's why. Oh dear, it should be a straight line as well. Let's use the line tool, probably be better. But I bet you this is going to be too thick now. So that point there, if I've drawn it correctly, which I won't have done, but if I had, would be at 17 on the y-axis. And it won't ever go lower, the curve will keep on going. So that would mean, going back to the question, that it will the value of this, no matter what value of n we use, whether we go up really, really high, or even if we go into the really negative numbers, it doesn't matter how far you go, you could go infinitely into the negative direction, you would still get a positive result because your curve is going to look something like this. Yeah. By the way, that picture, no way to scale. Alright? But that's the way you'd have to prove it, is writing it out and spotting this pattern that this is your lowest value and that the numbers either side are then going up. So they're going in the positive direction. So you imagine you've got your number line, you've got 17, 18, 19. Nothing is going to go below that value. Alright? Hopefully that answers the question for you, Jamie. If not, ask away. Right then, the next question I was asked about was how to do the work with quadratic sequences. So we're going to go through how to, and there is another video on this. If you look on the channel, you'll find another video on this. But I'm going to go through how to generate an extra term. I'm going to show you how to work out a particular term, and then I'm going to show you how to do the nth term. And it's remembering that step by step. I haven't included the step by step on this, so if you need it, you'll have to flick back to the previous video and make notes. Apologies for that, I didn't put that together beforehand. So what we'll do, here are the first 5 terms of sequence: 2, 8, 18, 32, 50. Find the next term of this sequence. Not much space there, so first things first, I'd write out the sequence again. So I've got 2, 8, 18, 32, 50. Write them out there. That looks like 56 now, doesn't it? Let's undo that one. 50. Still, it looks a little bit like. That's better. Then I would be looking for what they're going up in. So that goes plus 6, that goes plus 10, that goes plus 14, and that goes plus 18. So to find the next term in the sequence, I'd like to think that you would now all be able to spot that that's going plus 4, that's plus 4, that's plus 4. So the next one will be plus 4, which means we'll be adding 22. Which means that the next term in the sequence will be 72. Apologies, you can't see that there's a 50 just sort of off the screen over here, but I've included that here. This is from the unit test that I sent you the other day. Right. So just to recap what I did there, wrote out the sequence again, worked out the first difference. If this was a linear sequence, they'd all be the same. It's not. I then work out the second difference, which is plus 4, plus 4, plus 4, plus 4. That's always going to be the same now, so that means it's a quadratic sequence because it's the second difference. So then I can carry on. I've got plus 6, plus 4, plus 14, plus 18. So the next one, I just add 4 to that to get plus 22. And then I add 22 to 50 to get 72, which is the next term in my sequence. So the correct answer is 72. Which again, you're not going to be able to see that, are you? Wait a few seconds for it to appear on my screen. I don't think you're going to see it, so don't want to do that. Yeah, you'll be able to see it now. All right, next question then. The nth term of a different sequence is 3n squared minus 10. So work out the fifth term of the sequence. Well, you could do what we've done before, and you could do n 1, 2, 3, 4, 5 and work it out like that. But actually, you only want this one. So all you've got to do is substitute in 5 for n. And then remember your rules of your order of operations. So what would happen first with this one? You've got 3 multiplied by 5 squared minus 10. So what would you need to be doing first? In this case, all you would do is do the indices first. Do the indices first. So it's 5 squared, which is 25, multiplied by 3. And when there's a coefficient in front of the brackets, means multiply. So 3 multiplied by the 25, 75. Subtract the 10, gives you 65. So if you want me to write that out in full, that would be 3 brackets 25, because I'll do the indices first, minus 10, 65. We don't know what it equals yet. Minus 10. Then that's 75 minus 10, and that will equal 65. Hopefully you could see that from there. So the answer to this one is the 5th term of the sequence is 65. Righto, next one. I think, James, you were asking about this. There is another video on this, and if you need to, I strongly recommend going back and looking at that, because there is a step-by-step guide. I'm not going to write out a step-by-step guide off the top of my head now, because I can't remember. I don't want to contradict what I've already written. So just go back and watch that. But I will take you through the right steps, or I will talk you through the right steps. So, firstly, not much room to work with the question here. So, it's 3, 13, 27 and 45, and that sequence would carry on. So if you ever see 3 dots, that just means it would carry on infinitely. Find expression in terms of m for the nth term of this quadratic sequence. Well, it's quite nice. It's telling us it's going to be a quadratic, so that means we are looking for n squared, and there could be an a value potentially, but I doubt it. Well, there might be, we'll see. And then that means we've got to be looking for our second difference. So let's crack on, shall we? So here we've got plus 10. We've got plus 14. Oh, maybe there is an a value. And then we've got plus 18. Those are not the same. So it's not linear, but we know that from the question because we're told it's quadratic. So we go down here to work out our second difference, which is plus 4 plus 4. If you're told it's quadratic and you get to the second difference and it's not the same, then you've made an error somewhere up here. So you just need to check that you've worked out your differences correctly. But here we've got plus 4 and we've got plus 4. Brilliant. So what we always need to do at this point is whatever this value is here, we do that value, which really I should do in green because I've done it in green there. We do that value, and we always, no matter what it is, we divide that by 2. And in this case, that's going to be equal to, I'm going to go back to blue, or I don't know, probably, I'm going to use sort of an orangey colour, is it orange or I'll use red again? I'll use red again. That value is your a value. So whatever that value is there is the value that is your coefficient for your n squared. So that means that in this particular sequence, it will be 2 n squared. Now this is where you've got to remember again that n just means the term in the sequence, the place value, the term number, right? So when n is 1, have I left myself enough space there? No, I haven't. So n is 1, 2, 3, 4, 5. And we know that it's going to be 2 n squared, because this value here is 2. So if you divide that number by 2 and you get 1, then it's 1n squared. If you divide that number by 2 and it's 5, then that's 5n squared. So whatever that number is, divide by 2, this becomes your a value, your coefficient for n squared. So then what you have to do is you substitute in your n values into 2n squared. So 1n squared is 1. So 1 squared is 1 multiplied by 2. Let's put this in a different colour. Like an orange, there we go. No, let's put it in a sort of a purpley colour. 1 squared is 1 multiplied by 2, 2. 2 squared, 4 multiplied by 2, 8. 3 squared, 9 multiplied by 2, 18. 4 squared, 16 multiplied by 2, 32. 5 squared, 25 multiplied by 2, 50. What we then do, if you remember back to our notes from before, is we do our original sequence, subtract 2, n squared. So back to our original sequence. What colour are we going to use now? We'll use yellow. So our original sequence, subtract 2 is 3, take away 2, 1. 13, take away 8, 5. 27, take away 18, 9. 45, subtract 32, 13. And in this case, we don't need the 50 because we haven't got another term here. So, we've gone a bit too far. So, just to recap, we've done first difference wasn't the same. Second difference was the same. Second difference, we divided by 2. Whatever that value is the coefficient for n squared. We know it's a quadratic because it says so in the question. We then do our first 5 or first 4, depending on what you've got in the question, n squared, 2n squared numbers. So 1n squared times 2 multiplied by 2. 2n, not 2n squared, sorry. We substitute in 1 for n. So 1 squared multiplied by 2. 2 squared multiplied by 2. 3 squared multiplied by 2. 4 squared multiplied by 2. 5 squared multiplied by 2. And then we do the sequence, subtract those values. So original sequence, 3, subtract our 2n squared. So 3 subtract 2, 13 subtract 8, 27 subtract 18, 45 subtract 32. And that's given us this other sequence. So basically what you're doing is you're subtracting the quadratic element, which will leave you with a linear element. That's the way I like to think of it. So what you've got to do then is you've got to try and solve this linear sequence. So here we go up by 4. Here we go up by 4. And here we go up by 4. Well, if it's a linear sequence, the first difference is the same. And that is the case here. We've got 4, 4, 4. So this is your coefficient of n. So we've got our coefficient of n squared. This is your coefficient of n. So it's 4n. So now, if I sort of go back to the top so we can start building our answer, we've got n squared plus n. So we've got, it was 2n squared. We've got 4n, but we haven't finished. Because if it's 4n, That means 4 multiplied by n. That would mean that it's the 4 times table. Yeah, 4 multiplied by a number is going to be the 4 times table. But I don't start with 4. 4 is the first number in the 4 times table. I've started with 1. So what you have to do is you have to look at what's the difference between that number and that number. How do you get from 4 to 1? So in this case, what am I using? I think I've used green. Well, I haven't used it for a little while. 4 to get to 1 is minus 3. And that number goes here. So this sequence is 4n minus 3. So let's just check. So that's the first term in the sequence. So 4 multiplied by 1 is 4, minus 3 is 1. 5 is the second number in the sequence. 4 multiplied by 2, because that's the place in the sequence. 4 multiplied by 2 is 8, minus 3 is 5. Yes, that works. So what that then means is that when we go back to this bit at the top here, you've got 2n squared from that 2 there. You've got your 4n from when we've done the sequence, subtract the 2n squared, because the common difference here is 4. So that's where that 4's come from. And then finally we've got this minus 3 at the end. It is a long-winded question. It is difficult. We will go over it again, not only when we're back, but also in year 10. So don't panic, but just have a go. See what you can do. Try your best with it. Key is look for the second difference, divide it by 2. Whatever that number is your coefficient for n squared. N is just the place in the sequence. So the first, second, third, fourth, fifth term. So we do that multiplied by your coefficient. So that squared multiplied by your coefficient. Subtract it from the original sequence. And then work out this linear sequence. What's going on here? The common difference is plus 4. So the multiple there is 4. If it was 4, we'd expect, or as it is 4, you'd expect the first number to be 4, but it's not. It's 1. So how do I get from 4 to 1? It's negative 3. And if you look, each of these numbers is 3 less than a number in the 4 times table. 3 less than 4, 3 less than 8, 3 less than 12, 3 less than 16. And that gives us the final answer of being 2n squared plus 4n minus 3. Right, one more, I think. Fibonacci. Don't think there's anything else after Fibonacci. No, there isn't. Right. Someone asked last week about Fibonacci. I think that was Alina. So here are the first 4 terms of a Fibonacci style sequence. We've got 3, 6, 9, 15. Write down the next 2. Fibonacci is pretty simple depending on the type of numbers you're dealing with, because all it is you do 3 add 6 to get 9. Then you do 6 add 9 to equal 15. So you add together the 2 previous terms to get the next one. So to get the next term, you do 9 add 15, which is equal to 24. So that number is 24. And then you do no, you don't do 24. You do 15 add 24, which is 39. And that's as simple as it is. So you just add the 2 previous answers to get the next. Okay. The only thing I want to add about this is that you might have to think about it algebraically. So if you imagine that your first term of a sequence was A and the next one was B, how would you get the third term? We've got to add those 2 together. So your next one would be A plus B. So what would the fourth term be? Well, the fourth term would be this, add this. So it would be A plus 2B. And then the next term would be this one, add this one, the previous two terms. So you'd end up with A add A, which is 2A, and B plus 2B, which is 3B. And so on and so forth. So don't be scared of there being algebra. It's not something to be scared about. So this is Fibonacci. I've spelled that right now. I have to look back. Yeah. With algebra. Alright, so A, B being the first two terms, you then add them to get the third term. You add the second and the third to get the fourth. You add the third and the fourth to get the fifth. And so on and so forth. That should say algebra. That looks like algebra. That's going to bug me. I have to rub it out. Algebra. Alright. Right, have a watch. Tell me what you think. If it's been useful, that's brilliant. Hit the like, subscribe, so that you can see when other videos are coming on. Doesn't matter if you haven't been able to see it today. I appreciate it's come on late. I had connection issues this morning, but just one of those things. Let me know what you think. Hopefully you find it useful. If you're still struggling with anything that you've emailed me about, email me again. I do try and get back as quickly as I can, but that's not always straight away. But please, please, please get in touch. Hope you're all well. Stay safe. Take care, guys.